So you don't have to use SQL with Spark SQL necessarily. You can also just call functions directly without actually relying on the SQL syntax itself, and that can be a little bit more efficient. So let's see how that works. Let's take that same set of data, the fake friends data, and analyze it a different way. So I've gone ahead and imported the DataFrames.scala file here into my project. Go ahead and hit pause and take care of that if you need to. And let's take a look here. Again, I'm importing the SQL package from Spark. And a lot of this looks the same, so we're starting off just like we did in the previous example where we create a Spark session using the name Spark SQL, every core of the computer, and this little hack that we need on Windows in order to get around a bug in Spark 2.0. So again, make sure you have a C temp folder on your hard drive, and if you're not on Windows, remember to take that line out. All right. So just like before, we're going to load up our fakefriends.csv comma separated value data and use this mapper to convert it into a structured piece of data where it consists of an RDD of person objects. And then like before, we're going to call 2ds on it, which can take advantage of spark.implicits to actually convert that RDD into an actual data set where it knows what the actual format of the data is at compile time. And we're going to cache that data set because we're going to do more than one thing to it. So we want to make sure we don't have to reconstruct that every time. Okay, so let's see how that works. We'll print the schema like we did before, make sure that it's still correctly inferred the structure of our data and the types of that data. And we'll have some fun with it. So let's start by selecting the name column. So remember, this data set is just like a database at this point, and I can do SQL-like operations on it. But instead of actually calling spark.sql select name from, some temporary view that I created, I'm going to operate on the data set directly here and call people, which is, again, a data set of person objects, dot select the name column, which again was inferred from our case class up here. Just by the virtue of it being called name up here, it was able to infer that column number 2 is called name and contains string data. And we'll call show, which is just a way to quickly show the top 20 results in that data set. So a little handy thing for debugging purposes. Okay. Next thing we'll do is filter out anyone over the age of 21. So we just want underage people. Let's print those out like we did before. So we'll call people on our data set, call filter, and we can actually put an expression in there where we can say people age, that means the age column, less than 21. So it might surprise you that that syntax actually compiles, but it does. Scala's kind of cool that way. We can actually just pass in this expression and it will do the right thing. It will actually filter out anyone with an age of less than 21. It's a very natural syntax that just works and show the top 20 results of that operation. We can also do group by operations like you would in SQL as well. So what this is going to do is group up the entire data set by age and count out the number of every age occurrence in there. So that will give us the total number of 18-year-olds, the total number of 19-year-olds, and so on and so forth, and then show the top 20 results. Now you might remember we've actually had to jump through some hoops to do this before without using data sets. So to do this just using straight up RDDs and maps and reduce operations, that can be kind of a tricky thing to do, but very simple using data sets. So we just do group by age and count and we're done. Print that out. Finally, let's show how we can actually manipulate an existing column. So what we're going to do here is select the name column and actually take people.age, add 10 years to it, and show the results. So what we're going to do here is select out the name column and select out the age column, adding 10 as we go, and show those results as we go. Okay, so we're not actually changing the people data set itself, but we're going to extract it in such a way that we're artificially adding 10 years to everyone's age as we print out the results. So pretty interesting. You can do stuff like that as well. When we're done, we'll call stop on our session object, and that will tell Spark that we can stop what we're doing. So let's go ahead and run it. Go to the Run menu and Run Configurations. I already set one up, so go ahead and set one up yourself that looks like this. DataFrames with the project name and the com.sundogsoftware.spark.dataframes class name. Let's run that and walk through what comes out of it. All right, pretty quick. Let's start at the top and see what we got. So we started off with the same schema, and sure enough, it worked again. So we have our structured data here in our data set with an integer ID, a string name, an integer age, and an integer number of friends on each. Those are all of our columns for every row of our data in our data set. All right, the first thing we did up here was select the name column, and sure enough, that worked. So this is just printing out the first 20 rows in our data set, just pulling out the name. We then did this example of filtering out anyone over the age of 21 with this pretty neat syntax here that's very easy to read, and sure enough, it did work. Everyone that comes out of that operation has an age of less than 21. We then did that group by operation, and you can see it had to work a little bit harder for that one. But we got the answers we want, so here we are, 8 31-year-olds in the data, 17 26-year-olds, and so on and so forth. If we wanted to, we could have tacked an order by in that command as well to get that ordered by age. So just like you would do order by in a SQL command, there's an order by command, an order by function as well that you can call in a data set. And our final example here, where we added 10 to everyone's age on the way out, we ended up making everyone 10 years older in our resulting data set here. And here's an example of the results of that. So Wei Yun may have started off at 59 years old, but in our resulting data set that we printed out the results of, he ended up being 69. Poor guy. And there you have it. So those are some examples of what you can do. There are other functions you can do as well in Spark SQL too. Pretty much if there's a SQL command, there's probably a corresponding function that you can use as well. So it's sort of up to you if you want to issue SQL commands or do it in this style. I prefer this style because, you know, it just seems a little bit more direct to what you're trying to do. Seems a little bit more efficient to me. So there you have it. Let's do some more stuff with Spark SQL because, again, DataSets is a very important feature of Spark 2.0 and it's going to become even more important going forward. So let's soldier on.